one-sided limits. So on the illustration, figure 1 is a graph of a function y is equal to f of x, and here is the function. Suppose this is the function, and the limit value is equal to L sub 1, or the, the function f of x is equal to L sub 1. If a function f of x approaches a value L sub 1 as x gets closer to a number a, and if a is a number coming from the left side of the x-axis, so here is the left side of the x-axis, and a is coming from here, and x is coming from here, approaching a, we write the limit of the function f of x as x approaches a from the negative side is equal to some value L sub 1. So here is a one-sided limit where x approaches a from the negative side. Now on figure 2, on the right side, we have a graph of a function f of x, and x approaches a, and a is coming from the right hand side of the x-axis. But if a function f of x approaches a value L sub 2 as x gets closer to a number a, and if a is a number from the right side of the x-axis, then we write the limit of f of x as x approaches a from the positive side is equal to some value L sub 2. Okay? The value L sub 2 is said to be the right hand limit of the function f of x as x approaches a. The value L sub 1 is said to be the left hand limit of the function f of x as x approaches a. So that is how we illustrate one-sided limits. Now we go to some example. Okay. Here we have a graph, and this is the graph of the function y is equal to x over x minus 1. Now we try to find the left hand limit of the function f of x, or the function x over x sub 1 as x approaches 1 from the left side. To do this, we will assign a number from the left side of 1 but not equal to 1. And this could be 0.99. So here is 1. Okay? Here is 1. And x is approaching 1 from the negative side. So we're coming from the negative side, and x is approaching 1. So the closest number that could be nearest to positive 1 coming from the left side is 0.9999. Okay? Now, we try to find the left hand limit of the function f of x. Now we evaluate the limit of x over x minus 1 as x approaches 1 from the negative side is equal to, by substitution, as x approaches negative 1 from the positive side, from the negative side rather, we have 0.9999 9, 9. Now we place a bar on top of 99 of the digits 99 to indicate continuity. No? It is a never, it is a, as it is a repeating decimal, so we put the bar on top of it. Then on the denominator we have 0.99. Again the bar minus 1. So we're not going to find the exact decimal value of this of the quotient of this, but we will try to analyze what could be the possible result of this operation. Now we see that 0.99999 is a positive number, right? Now if we subtract 1 from 0.9999, we get what? We get a negative number. And so the limit value is a negative infinity. Okay? And this is from figure 3. And that, as suggested by figure 3, here it is. The value approaches downward, and that is a negative infinity. Now we go to the right hand side limit. Okay? On figure 4, we have x approaches 1 from the positive side, from the right side. Now we go to the limit statement of x minus 1. As x approaches 1 from the positive side, and x is coming from here, x approaches 1 from the positive side, and x is moving in this direction. Okay, so the closest number we can assign to x as it approaches 1 from the positive side could be 1.01. Okay, so here is 1 again, and x is coming from the right side. Now by substitution, minus 1. Okay. So the numerator is a positive number. Okay, and the denominator, if you subtract 1 from 1.01, again you get a positive number. So the limit value, or the right hand limit of the function f of x, or the function x over x minus 1, is a positive infinity. And this is shown by the graph. Here is the graph, and the value approaches positive infinity.